All right, so let's go ahead and jump in here. We have another, looks like a equals 3 squared problem. So we go ahead and put that 3 over here. And then we have x right here, and we put that 3. Put that 3 right there. 3 squared minus x squared. Again, if we want to check, we square that. And we square that. And it should equal that squared. And yes, that's right. All right, so we have an a equals 3 problem of type 1, a squared minus x squared. And so we're going to go ahead and set, since x is equal to a sine theta, and you can see that from the relationship here in this triangle, that because of your SOHCAHTOA rule, that the sine of theta is going to equal the opposite over the hypotenuse. And so that's going to let you know right there that x is equal to sine of x is equal to 3 sine theta. So we go ahead and write that down. It's all part of the preparation for a trig substitution. All right, here we have dx equals, let's see, I was about to put a negative. Cosine theta d theta. Okay, 3 cosine theta d theta. All right, so we're trying to do the integral of this thing. All right, now here comes the substitution. We have that this is equal to 9 minus x is equal to 3 sine theta. So 3 sine theta squared. Now the dx, which I should have been putting, the dx is equal to 3, as you can see right here, 3 cosine theta d theta. Excuse me. All right, let's see where we're going now. Well, the item under the square root is looking like it's going to be 9 minus 9 sine squared theta. And from our Pythagorean identity, we're going to go ahead and mark that down as 9 cosine squared theta. This is the generalized Pythagorean identity. Okay. And we're basically using that in every single problem here. All right, now let's look at this. There's a square root of a 9 and a cosine that's going to pop right out as a 3 cosine theta. But since we have a 3 over here, let's go ahead and call it a squared on that 3 and a squared on the cosine. All right, next step, very frequent step in these type of things, is that we're going to replace the cosine squared with the 1/2 cosine 2 theta plus 1 power reduction formula. All right, and so since it's a little bit messy with the parentheses, let's go ahead and clean this up and call this a 3 squared over 2 cosine 2 theta. And let's see, this 1/2 is going to multiply with the 1, which is also going to get a 3 squared over 2. Okay. So what we're looking at here now is integrating. And this 2 is going to stop on by to say hello down there. That's just the way that works. This constant number is going to get a theta attached. And And we don't have limits to plug in. I was looking for the limits, but we don't have any. Okay, now, the thing is that we don't usually want to leave a double angle in the answer. So since we are gearing up for an answer here, let's go ahead and say that this is 9. Let's go ahead and make this 9. It doesn't look like it's going to simplify. Sine 2 theta is going to become 2 sine theta cosine theta. This guy over here, I'm just going to leave it as theta for now. All right, so again, we're trying to simplify a little bit here. Now remember, up above, that sine theta, you can solve this, is x over 3. So sine theta is x over 3. Question is, what is cosine theta? That's kind of why we're setting up this triangle, right? Cosine is the ka part, adjacent. Let's see, cosine theta is adjacent this monster over the hypotenuse. Okay, that's particularly nasty looking. Let's go ahead and come down here and substitute it right there. So that's 9 if you simplify it just like that. All right, 9 over 4 theta. Now we also want to substitute theta. So from that same equation, and you're going to get used to reusing these equations a whole bunch, you're going to want to take, you're going to want to say, hey, look, let me pull it over here for you. Let's just make a lot of space here. X over 3 equals sine theta. You're going to want to take the arc sine of both sides. And arc sine is the inverse of sine. So arc sine of sine is just going to be the theta left over. So theta is the arc sine of x over 3. So let's go ahead and come on down here and say that this is the arc sine of x over 3. Okay, let's see what we have over here. Actually, this 9 with the 2 3s cancels there. And it looks like we're home free here. The only thing I would say is that I made a little bit of a boo-boo, it looks like. So 3 squared, let's trace this back. This 3 squared, so 1/2 times 1 is 1/2. 3 squared, 1/2. I don't know where this 4 came from. I was being too quick. This is 2, right? Okay, so let's go ahead and put a final answer down. Looks like we can, is there any way to simplify this? We have 1/2 x times the square root of 9 minus x squared and 9/2 times the arc sine. This doesn't look like it's simplifying very much. A lot of these end up like that. The key is that you just definitely want to get it back into the x variable because we started it in the x variable. The thetas were just part of the trig substitution. So, so yeah, that concludes that one.